Um, good afternoon. Thank you for attending this session. My name is Richard, aka the Aniki. Other people call me online. And I'm doing a talk about 3D scanning, something that I have been trying to do for the last 12, 13, 14 years or so. It's not my day job, it's purely my hobby. I'm a hacker maker kind of guy. I've had my first 3D printer in 2009, the time that 3D printers were still very challenging. I remember one of my first 3D prints was earrings for my niece, and it took me about 2.5 weeks to get one successful print. Nowadays, of course, life has really changed, God bless. And the same thing counts for 3D scanning. 3D scanning is actually a technology that's been around for a very long time. Actually, photogrammetry has been invented in 1892, I think. So really old technology. But it really has become extremely easy to use with current hardware, cameras, your iPhones, and those kinds of things. So that's really something that I wanted to show you today, that this is something you can do yourself. Doesn't require any money or little money, depending a little bit on what you do. So why would you want to 3D scan something? Well, there are many, many reasons for it. I, for instance, have a very shitty old van, a camper. And I had, for instance, that my sun flap mirror thing, the thingy was so old, the plastic was brittle and it collapsed. Now, the good thing about a car is that you always typically have 2 times everything in your car, right? So I took one that was still working, I 3D scanned it, hit print, and I had a copy of the thing. I didn't do any cleanup, I didn't design anything, and literally right now my sun flaps are working again in my car. Very happy with that. So if you need something physical copied, of course 3D scanning is very useful. You actually, funnily enough, see it also a lot where people want to capture something to later on analyze. I don't know if you've ever seen a crime scene. They don't just make photos, they typically put lots of scanners there as well, so that they can completely capture an entire environment, because you don't know upfront what you want to capture, so that later on you have all that information. And of course you can capture real things, art, people, and that's how my journey started. My journey started with a really hard problem, because I wanted to scan my son. And my son at that time was 3 years old, and he does not stand still. Until this day, he does not stand still, not even for 1 second. And that's difficult, because I wanted to have a statue of him. For some reason, I wanted that. And how do you do that? That's very difficult, because even this was 12 years ago, 11 years ago, there were already some form of hand scanners, you have a Kinect camera. Yeah, but all of those things require something to stand still. So I had to do it differently, and I did know that there was a technology that you can use photos to do, and this was exactly the same time when the Raspberry Pi came out with their camera, their first camera, and at that time it was relatively cheap. So I took a few Raspberries, I borrowed the room of my other child, and put some cameras on, wrote some software to make them take a photo at exactly the same time. And this, I think this was 14 cameras or something, and it already gave a result. So that was optimistic. So I went to my living room, built a little bit bigger scanner with a little bit more cameras. And nowadays I have this. Again, this is my hobby, this is not my work. But we do have this, because I also wrote the software, and I do sell the software. So they're all around the world. There's many 3D scanners that use my software. But this is 120 Raspberry Pis, cameras to do. Now, of course, this is not a cheap solution to do. If you ever do want to have a scan for yourself, feel free to come to me, come to Soetermeer, where this is. We'll make a scan of you. But today I'm going to actually show you on how you can actually do these kind of things yourself. But this is a little bit how my journey started with 3D scanning. And when I made this initially, I posted this on Instructables.com. I always like to post my project. You'll find many of my projects there. And I thought, no one is ever going to do this. When I did this, who else is going to buy 100 Raspberries Plus and cameras? But crazily enough, quite quickly on, someone already turned in that they made this project. I was really surprised. So never think about not sharing. It's always valuable for other people. Everything I do, I put it online, share it, and that kind of stuff. So always worth it. So how does this work? There's 2 main scan technologies I'll show you today that you can use yourself in daily life. And the first one is something called photogrammetry. As I said, this is a technology that's been existing since 1892, invented by some French military officer. And how it simplistically works is by taking multiple pictures of the same object, as long as the software or human being, whoever does this, in 1890 it was human beings, as long as they can identify the similar spot in the photo, across the 3 photos, you can do triangulation and you can figure out where that spot actually sits in physical space. So you need to have multiple overlapping photos taking the same identifiable spot at different angles. And if you do that times many, you can actually get 3D data. You get what's called a point cloud. You get points in space and then you can turn that into a mesh, a 3D object, and you can put color information on top of it and that kind of stuff. And in 2010, a Russian software company called Edgesoft made this available for anyone to run, as long as you had a GPU in your computer. You could do this yourself. You could just take photos, upload it into that software, and you can turn things into 3D models. And photogrammetry is great as long as the object does not move, right? So because you have to, if you do this at least with a single camera, the object has to stay still. Now that's why I had to use 120 cameras, because my child moves, so I had to take the 120 photos at exactly the same time. But you can do this with your phone. You can just, I'll show you later on, I went outside and I saw that there was a robot standing in front of the building here. I took photos of it and I have a 3D model now of that thing. So as long as it doesn't move, you can do this yourself with just your iPhone. Or any camera, a GoPro. Of course, the better the camera, the better probably your result is. What is really key is that the object you're trying to scan has texture. And if it doesn't have texture, you can't really scan it. So if I would want to try to scan that white wall over there, I'm not going to find identifiable points into that. So no matter if I have a high-end camera or a low-end camera, it's just going to stay white. So something needs to have texture. That's really very critical. And always think about it if you scan. And so like if you actually have a surface that doesn't have texture, you can spray hairspray on it and that gives it a bubbly texture thing. Don't try to scan glasses. It's see-through, doesn't have texture. And put a t-shirt on, even if for instance, if you want to scan yourself, put clothing on, even if you don't like the clothing, that has a lot of texture. Later on in your model, you can change colors, you can change all that kind of stuff anyway, so it doesn't really matter. If you're trying to scan something, a small object, put it on top of a newspaper. A newspaper has lots of unique identifiable pictures, and it gives you a great base so that the cameras knows where they are and that kind of stuff. So by doing those kinds of things, it allows you to very easily do this. And this is something, the software to do photogrammetry with, is extremely accessible. For instance, if you go on your iPhone or if you go on your Mac in the App Store, you find tons and tons of software that can actually do this for you. And some are free, some are charged, don't pay for it, because no one made this. None of these application vendors made this, because this is nowadays standard functionality in iOS and macOS. So in iOS and macOS sits a library, something called Object Catcher, that you can throw images at it, and it will turn it into a 3D model for you. So what other people did is just wrote a simple shell around it so they can publish it in the App Store as an app and try to get money from you. So definitely don't do that. But if you search enough, you'll find software that is there that's available for free. So just to give you an example, I have it here. There you go. So this is me and my son nowadays. He's a little bit older. I have it here printed, so you can see it later on as well. So this is actually made with my my multi-camera thing. And of course, this, as I said, this comes in full color, so you can do lots of things with this. But I also went outside, and outside, I don't know if you've seen it, you have this thing here. So I just walked around it, took many photos, and now I have a 3D model, and you can put this into Unity and put it into a game. You can, if you do some cleanup, you can print. I did it quickly, and the thing is quite tall, so I couldn't with my camera shoot from the top down on it. So I should have had a pole or something. So you see that the top is not so good, but actually it's a great start. And as I said, it's something you can just very simply do. You can run it on your laptop. You have an app for it. Many ways on how you can actually do this. So plenty of plenty of apps for you to run through this. Now, this is all for Mac. As I said, Mac has this technology built in. But on a PC, if you're a PC person, I'm usually doing this on a PC, you also have something else, something called Reality Scan. And again, there, really things have changed. This used to be very expensive software, but Epic bought them. Epic is a game maker, and they want to promote people making their own objects to put into games. So while they bought this company, paid lots of money for it, they made the software completely free available. So this is super high-end software. They have been market leader about photogrammetry for the last at least 8 years. It's by far the best photogrammetry software that's there. You used to pay lots of money for it. It's completely free for you to use, but it does require a PC. So you have to have a PC with a GPU. So this doesn't unfortunately run on a Mac. They do have a mobile app, so you can do it on your phone. The nice thing, the mobile app actually doesn't make the model. So the mobile app allows you to take all the pictures very easily, and it uploads those pictures in the cloud. They turn it into a model for you and send it back to you. So if you don't want that, you can get the local software to do. Now the great thing with this software and with photogrammetry is there are lots of things that you can then enhance of it. You don't have to just take photos, you can also take a video. So if you want to do a really quick scan, you just turn your camera, your phone in video mode, run around something in many angles, and then you can just throw it into that reality scan software and say, take from the video every 0.1 second a photo, and it will automatically do that and turn it into photos to do. So very, very simple in that way. Now, if it has texture, I'll show that. You can actually use it in the model as well. Now, the great thing is that with photogrammetry, from photos you can make 3D objects. And I can make the photos myself, but you can also, without a camera at all, use existing photos. And you have seen this actually in the past, that people have been doing this. So I don't know, remember a few years ago in the Middle East, ISIS destroyed all the statues at the end of a war and that kind of stuff. People were really upset about that. So people went online finding from these statues photos taken by tourists. And as long as the statue is always the same, roughly speaking, and you get photos from tourists taken from all angles, you can throw them in software and print them out again. So while those objects got lost, there was a whole initiative of getting those pictures and turning those objects back into life again. I think it's a really noble cause in the way in how photogrammetry can be used. Another example that I have been using a lot lately, because I found it really funny, is I use Google Earth. So this here, and you can see it later on if you want, this is a 3D model printed of a location. This location here where we are, we're actually in this building here. So this is the Polaroid factory and all that kind of stuff. I did not fly a drone around here. I don't live here, and I already made this last week. So all I did is I went to Google Earth, turned a video recording on of my screen, and I pretended to be a drone. So I just, with my mouse, was flying through this area. And I took that video, put it into that reality scan software, and turned it into a model. And I'm really surprised on how well that turns out. I have one of my own neighborhood where there's bridges, and you can actually see underneath the bridge and all that kind of stuff. The trees are the hardest thing, I find, because Google Earth shows you the top of the tree, but the tree stems are usually not there at all. So the green stuff is flying in mid-air. So if you print it, it will print mid-air. But the plastic will still fall down, and if you're lucky, you still get a tree, or you spend some time cleaning up the model, of course. I didn't. So all the I have two examples. If you want to see them later, they're completely raw. So raw scanned, did not do anything with it. Another nice thing about photogrammetry is that with photogrammetry, you don't just try to make the 3D model, but you capture the color information, the texture information. And what you can do with that texture information is something called bump mapping, a displacement map. And you can say, okay, if something has an average color, leave it the same, but if it's brighter increase the height, and if it's darker, decrease height, or the other way around, whatever you want. And then I can take a very rough scan that has poor quality because I made a pure quality scan, but if I have good quality texture, I can turn that into an incredibly high dense 3D model to use. And this is really great technology if you want to print in single color. So for instance, if you're wearing a t-shirt with some cool logo on it, if I would 3D scan it, of course, that logo is flat. It wouldn't come out on the print at all. But by doing a bump map, I can literally raise that logo very easily out of that t-shirt so that even if you print it in single color, you get to see that kind of details. Same thing for jeans. The line in your jeans is a really cool one to always bump out. It shows fantastic extra realism to your scan. So if you learn those kinds of tricks, literally with just your phone camera, you can make truly incredible kind of scans. Now there are limitations with photogrammetry. Surfaces that are difficult, glass, reflective stuff, super hard, pure black, pure whites, and anything that has no color, then it's difficult. Now if it's fabric, if you put a lot of light on fabric, you still get to see detail, so make sure that you use a lot of light. And one thing about photogrammetry is that photogrammetry has utterly no understanding about real sizes. It doesn't know if something is a meter or a kilometer big or whatsoever. It only knows ratios, because that's what it does. It measures ratios on the points it identifies. So to make something in 1-to-1 scale or 1/10 scale exactly, you have to do this. Unless, again, and with reality scan you can do this, you use markers in your scan. So the way and how we are, and I use this on my big scanner, but you can use this yourself as well. These markers, they're somewhat like QR codes. You can just print them out on a piece of paper, ideally on like A3 format, and as long as you space them specifically, the middle points on a distance that you know, so in my case it's 60 by 40 that they're printed on A0, but you can do this in small as well, and you know the size now. In the software you can say detect markers, and you can actually give the markers then a coordinate saying this is 0,0, this is 60,0, 60,40, 40,0,40. Now it knows real sizes and it is super exact, and it knows what the floor is. So my model is automatically also perfectly upright, coordinate function, that kind of stuff. And this technology, if you do this well, with a simple camera, is way sub millisecond, millimeter accurate, the scans that come out. So I had a student a few years ago that come to me for my scanner project because I said I open source it, and he wanted to make a hand scanner for people that have arthritis to make custom braces. They in the end developed a machine based on this, but then smaller, where you can stick your hand in, makes with Raspberry Pis many pictures, and based on that they can print a custom brace that's perfect exact. And they're actually now a large company. They have 100+ employees. They sell this around the world to hospitals using this technology, using this software. And they also use, of course, the markers for that accuracy. So that's what photogrammetry is. Something you can do, and I said the software nowadays, it's free available. As long as you have a camera or you're good at stealing pictures from Google Earth or somewhere else, you're good to go. You can do this anywhere you want and that kind of stuff. Now another technology that is very popular now and is very accessible is a technique called depth sensing cameras. This is a different way of 3D scanning. And depth sensing scanners is also called active 3D scanning. It doesn't just take a photo of existing light, it actually it emits light. And it can be laser or typically it's infrared. And what it does is it just projects a certain pattern on something. Imagine if I would project a line on something, like if you have one of those laser lines from the Home Depot. And if the surface has a bump in it, you'll see that the line distorts. And by seeing that distortion, you can actually then again measure the depth of that object. Or if you do it with infrared light, you can flash it very quickly and you can measure how quickly the dots are being reflected, and that's called time of flight. In that way you can measure this as well. And this is actually something that is built into your phone, at least if you have an iPhone. This is, for instance, how your Face ID works. Your Face ID in the front there is a camera, and not just a camera, there is a light emitting infrared thing. So this, if you literally take a camera that can see infrared, this is what you would see if you're scanning, if you're opening up your phone. It emits all these dots. Based on that, it can figure out if it's your face to do that. And in your iPhone, I don't know if it's with Android, but in your iPhone you have it to unlock, but you also have one on the back. So on the back thingy there's also a LiDAR scanner. So with this, you can actually scan an environment as well. Now, these dots are not super dense or accurate, so you wouldn't be able to scan something small with it or something like that. But you can absolutely scan a large room with it. So let me give you an example. If my technology works. So here I have this, and this is, for instance, oh, I'm seeing it here, not there. Why is that? I did test this. Let's see, is it? There you go. So this is my office room at home, fully 3D scanned, and you can see all my mess that I have and that kind of stuff. And yeah, this is something that you can just, and this is the nice thing about this form of scanning. This is accurate. So this is actually heavily being used for people that want to later on take measurements. If I now walk into Home Depot or something like that, shit, I need to know what this distance is. I can measure it in here, and it's going to be accurate. Because this type of technology actually understands, it knows the pattern of dots. If it sees it at a different distance, it actually knows the actual sizes of things. So you can make very accurate sizes. Now, this is great for room scanning. So if you wanted to scan this room, this LiDAR thing is fantastic. But it's not really good for objects, that kind of stuff. It's too small for that. So to improve that, to use this technology for other things, you can use hand scanners, and I have one here, and if you want later on you can call me and I'll scan your face or whatever you want. And this used to cost 15,000 euros. Even 5 years ago this was still 15,000 euros. Creality, I don't know if they make the cheap 3D printers. They now also make hand scanners, and it's still not super cheap, but it's getting there. Their cheapest scanner is 400 euros. This one, I have the Otter, the one is $1,000. Yeah, it's expensive. But for a hand scanner, it's not. And I'm hoping in the future this even will go down. And this is really accurate. So, just to give you a scary example, this is my face scanned with this hand scanner. And of course, when you scan, it scans without depth, right? It doesn't. It scans the shell of my face. So this shell is extruded inside, so I have wall thickness, so I can hold it. And this shell here is extruded the other way. So this fits exactly. And of course, this doesn't fit exactly on this because it is my face. This fits exactly on my face. So you can use this to make masks, whatever you want, or just scare people. Do whatever you want with it. So lots of things that you can actually do with that. So hand scanners are really now accessible. At least, well, I think 400 euros. And even though the prices are quite different, you will find that the quality difference is actually not that great. So, I mean, they have scanners up to 3,000 euros. And they're a tiny bit better. So you don't spend too much money. The only thing is that some of them can scan larger and they have blue laser lines that can handle more difficult services. But this is really great technology if you ever want to copy things in the real world. Car parts, those kinds of things. Actually, it's heavily being used. So if you have an old car where things are not being produced anymore, and as long as you have two of them, one is broken and one is still in the correct thing, you can scan it very easily and make that. So that's depth sensing. Very accurate, real sizes, also sub-millimeter accurate, very easily. It doesn't do all surfaces. Depending on how much money you spend on the scanner, some can do more, also the really difficult services. But again here, if you just use something that is reflective that you want to scan and you just spray hairspray over it, you will see that you can perfectly scan it. You can buy official 3D scanning spray, it's just hairspray, or people use chalk powder, those kinds of things to do. And you can get really, really good quality. But yeah, it does require you to buy extra hardware. And the texture typically is crap. Because what it does, it scans, and while it scans, it also takes photos, and it uses that later on to give color to things, but it's nowhere near what photogrammetry does. So if you want to have something that you want to scan to put yourself into a game or to put an object into a game, so in 3D, use photogrammetry. Because then actually the quality of the mesh is irrelevant. You typically for a game you have to bring it down to 10,000 polygons or something like that. The texture is then important. It is incredible how good that texture is. So if I give you an example, let me share. So this is that 3D capture reality reality scan app, the one that also makes the PC software, but you can do it here. And this is, so I have it here in small. This is Bob Ross. I hope you know who Bob Ross is. But this is, if you see from a color perspective, this is just made with my phone. And I have it 3D printed there as well. Now, of course, if you look at this from a 3D print perspective, yeah, it's not. So the bottom is not so great, and but 5-minute work in a 3D modeling software, you can flatten those things out and that kind of stuff. And especially then if you do the bump mapping on the hair and that kind of stuff, it's incredible. And the quality of this for things, especially like that actually have good texture. So this is my child's dino. It's amazing how well this is. Imagine putting this into a game or something like that. It's super simple. Oops. To do. Again here, the mesh quality is, it's okay-ish. At least it's very clean because it's a good texture. But this is something that you can do for free, no cost, no equipment needed, just your phone. And whatever you see in the real, how do I turn this off? In the real world, you can scan it using or photogrammetry, or using LiDAR in your phone or a hand scanner and those kinds of things. So if you ever want to go, I'll put this on so you have all the information. If you want to talk more or see more, you can go. I have a table there that you can come and see me. If you want, I have a scanner. I'll scan whatever you give me and share the files with you. Could be your face, could be whatever you want. And if you have any questions, feel free to ask. So the question is, can you scan? So can you scan with a 360 camera, right? Yeah. So yes, you can. But of course, a 360 camera's resolution is relatively low because it's in 360. It's typically 8K, right? But yeah, that should work fine. And so again, as long as you move it a lot around, the software can handle it. So the photogrammetry software, I know at least Reality Scan can work with GoPro, so anything that has super wide angles and those kinds of things, it can absolutely work with that. Yeah, yeah. It actually knows. So Reality Scan, or it's called now, I don't know, they changed the name. It actually reads the EXIF information from your camera. It therefore knows what lens it has and even can compensate for lens distortion. So, and therefore you get really accurate sizes because actually it knows, depending on the lens, if something is more wider seen than other things and that kind of stuff. So that's how advanced it actually really is. And the cool thing is, that's new something in that software, and they all now do it. They can do fully auto masking. So imagine that I have a thing standing here, like I went to scan outside that robot, and I wanted to scan that. Of course, the surroundings of it will change. People will walk by, and a car will pass, and that kind of stuff. So what the software fully automatically does is it understands I'm trying to scan what's here in the middle, and will create masks around everything else to take that information out. So you won't get any dirt on your scans from whatever else changed in the surroundings. Normally, a few years ago you had to do this all manually. It's super annoying. It's fully now with AI, it detects it, auto-masks it, done. So very, very easy to do. Any other questions? Yes. Yeah. So so when you do active 3D scanning, so when the scanner has to project light on it, the limitation really is on how dense it and sharp it can project that. Now, I said your phone is super not high resolution. This hand scanner can scan objects from 1 millimeter upwards. But like an insect, no. An insect, if you want to scan an insect, you would use macro photography and take picture. The animal needs to be dead, needs to not move. But if you do proper macro photography, and especially if you do with the layers that you can get the whole thing sharp, you would be able to get super high quality scans of that. Yeah, yeah. You would have to do photography. I don't think you would ever be able to do that. I don't think the density of the projection would be ever dense enough, tiny enough to do it on such small objects. Yeah. Oh, the outside, yeah, of course, yeah. Or you can take your phone and walk around it, make it, and you can say, I made it myself. I did it quickly. So I had 120 photos I used. And I said I wasn't tall enough to get, because it's a big one. So if you do it a little bit better, then you can even make it. Yeah, I'm happy to share that with you. Sure, no problem. Okay, yes. Yeah, to use a Kinect camera. Yeah. So a Kinect camera is really cool to make like those sand boxes where you project on it and do the display map. But the density of a Kinect camera is super low resolution. So from an actual 3D scanning perspective. Oh yeah. I don't know because Microsoft started locking down the driver. For the Kinect, that used to be very open. So I don't know. I have not seen in the 3D scanning world people using the Kinects because they're designed for high frame rate, but relatively very low resolution of dots that they project. They need to detect motion and that kind of stuff, which is the opposite of what we want to do here. So yeah, I don't think it would be worth it investigating that. Yeah. Okay, though. Well, thank you very much for attending. I said if you want to see anything, if you want to get something scanned, I'm here all day. Feel free to come visit me. Thank you very much.